The speed at which a wave unfolds in reality leaves us little time to understand it. It is therefore useful to be able to simulate a wave, to modify its speed, and even to be able to stop it. We can thus analyze quietly the way in which it is formed, and understand the modification of the slopes, according, for example, to the direction and the power of the wind. The Shapewave Dynamics software makes it possible to modulate the passage of time in a 3D wave to understand what is happening there. So here we see a wave which has wind speed and direction parameters of around 37 km per hour and an offshore direction. We will see that we can modify the structure of this wave and the way it behaves depending on the speed and direction of the wind. So here we have wind of 37 km per hour offshore. So we can show the slopes or the altitudes and the geometric structure of the wave. What will interest us here is to see how the wave changes shape depending on the wind. So we're going to take it back to the beginning, go to start. Give it a little faster speed, and observe it well. We see our wave forming. The wind speed being quite strong, we see that the surface is a bit blurred, and we see wrinkles on the surface. So here we have a fairly hollow wave. It's a wave of about 1 meter 20, it's quite hollow, due to the offshore direction of the wind. So we can observe it, stop on the image, and go around the wave, to observe it from all angles, and understand how it is formed. We are going to take exactly the same wave, same bathymetry, same period, same length, but modify the direction of the wind. We are going to put an onshore wind. Here I change the wind direction to onshore, and so I apply it to surf space. The structure of the wave will change, the direction of the onshore wind will give a less hollow, more crushed shape, which we know in onshore. I restart the wave, go to start, and slow down a bit. Now the wave no longer digs in and throws up its foam without really breaking into a hollow. The speed and direction of the wind therefore modified the shape of the wave. And so in our modeling, we will manage the stiffness of the waves with the wind parameters. We could also have applied a wind parameter here at 5 km per hour and reshaped the surface. At low wind speed, the change in wind direction from offshore to onshore will slightly modify the shape of the wave, but we will still widen the wave a little if we put an offshore wind direction. So here we have a wind of less than 5 km per hour onshore. We have a wave that doesn't really deepen, but a fairly smooth water surface. So all these waves are generated with the same wave parameters. Now we apply the offshore direction, and I reconstruct the wave, and we're going to see that it's going to be just a little bit more hollow, but the wind speed is low. It's not going to change the structure of the waves much. We watch it go by, so it's slightly more hollow, and forms a cleaner tube, and less flattened than onshore. We can thus test our boards in different waves. We can therefore modify the structure of the swell with the swell and bathymetry parameters, but also the steepness of the slope according to the wind and the direction of this wind. We will end this tutorial here, showing how to modify the shape of the wave with a wind parameter to test a board in different slope conditions with Shapewave Dynamics software.